Hi dudes, I am sorry that I am late. Nice to see that you've been chatting away. That's good stuff. I'll have a little look through that towards the end of the video as well. That's really nice to see. So glad to see you all here again for the daily exam question or daily revision question. A bit of feedback on yesterday's last one. Here's the next one. So this phone that I'm using right now to broadcast to you can be charged wirelessly using electromagnetic induction. Explain how the wireless charger works. So there's a picture of it in the thing. I was planning on bringing my own one, but I forgot. Details of the design and operation of it. So A-level students, make sure you refer to the correct law of physics to justify the choices in the design and operation of the wireless charger. So that's a tricky one for your A-level kids. There is a clue as to get you thinking on the right lines. I put this thing in. Oh, that is heavy. That is a clue. So I'll leave that there. A clue to what you need to be thinking about to kind of answer this. And always think explain questions are going to go down a similar kind of pattern to every other explain question. It's just a different context. So this is the context of wireless charging in phones, but it's a similar sort of explain question as a lot of other ones. Wow, that is really heavy. Okay, or am I really weak? Let's plod on with some feedback from last time. Again, Rachel's was the excellent GCSE one. They're all really, really good. Some of those that were sent to me by email, they don't like to be sharing their things online, but it's really, really good, the ones that come to me by email as well. So don't, I want you not to feel shy, and I want you to feel confident to actually go ahead and put that on the internet. When you explain when you explain the data that Hubble collected, it's enough to say measure the redshift of different galaxies. But there was lots of nice detail on like how he might do that, using a spectrometer to split apart the scope and look for the absorption lines in the spectrum. That's really good detail. And then maybe use those with comparison to a stationary source and see how much they've been redshifted from where you'd expect to see them. So that was really, really good. But the main thing, all we need to do is that the light has been redshifted, which means the wavelength has increased because the galaxies are moving away from the observer, and the observer is us, or Hubble, here on Earth. Didn't need the detail about accelerating rate for GCSE or A-level actually, but there was some really, really good detail in there, okay? Now, the A-level detail, that Lane's response was excellent. So I have a little read through Lane's response in the last video. Talked about Hubble's law, which is V is equal to H naught D. In other words, V, recessional velocity, the speed that the thing is going away from us, is proportional to its distance from us. And there is a constant proportionality called H naught, which is Hubble constant. So if you plot basically V on the y-axis, D on the x-axis, you get H naught as the gradient of the graph. Hence, so this looks very much like a y equals mx graph, and it did indeed go through the origin. Now, the Hubble constant has inverse time units. So essentially, its units are seconds to the -1. Now, Lane explains it's really kilometers per second over megaparsecs. But those kilometers and megaparsecs are 2 units of distance, so they kind of cancel to mean it has inverse time units. And actually, if you do the maths, if you follow through Lane's maths, it's very, very good. You come to a conclusion that the universe is about 14 billion years old. Now, he says at the end of that, why does he not get that 14 billion years, or 13.8, which is the kind of accepted value that you kind of need to learn for GCSE or A-level, because we're still at the point with these that different methodologies lead to quite different actual values for H naught. So there's still quite a lot of uncertainty in our understanding of the value for H naught, about 10% uncertainty actually. So one value comes out, and then they have to sort of decide whether to include it in the kind of running average of the age of the universe, if that makes sense. Where do you get distance from is a difficult one, and you don't need to know this for GCSE. You use what's called a standard ruler. You just kind of need to be aware of this for A-level, that there are objects in the universe that we know the rough size of. And basically, spiral galaxies, when they're in that spiral shape, including our own, are 22 megaparsecs across. And a megaparsec is just a parallax angle, basically, that links to a certain distance. So you can use them as a standard ruler, because you can then just measure the angular diameter of these you can just measure the angular diameter of these galaxies, and then you can just, from that, with trigonometry, you can work out distance in the unit parsecs, and obviously you can convert that into SI. So distance comes from standard rulers, and yeah, I think that's it. I think that's it for that feedback. So that was the last question about Hubble's law. Really awesome answers. Really, really pleased with these, especially read through Lane's stuff. You know, really good explanation. And, you know, even if you're GCSE, you do need to know about this graph. Recessional velocity, the speed of the galaxies away from us is proportional to the distance from us. If you're A-level, then you need to know and be able to use Hubble's law. The speed of a galaxy is h0 times by the distance from us. You need to be able to do that and make calculations with that and be able to use gradients from graphs like that. So really interesting one. You just need to understand redshift. Redshift is Doppler effect, but on light, basically. And because objects are moving away from us, they're emitting light of the same wavelength, but it appears to us redder. It appears to us longer wavelength. So we say it's moving towards the red end of the spectrum. I'll just read out the next question, and then I will have a little look through the chat. So, how does wireless charging work? This is not a wireless charger that I was hoping to bring to today's chat. And basically, this phone and many of your phones now can be charged wirelessly using electromagnetic induction. Requested question. I'll do a couple more on EM induction the next little while. Explain how the wireless charger works, giving details of the design and operation of it. So that's everyone can do that bit, and then A-level students need to just add this little bit. Refer to the correct law of physics to justify the choices in design and operation of the wireless charger. So think about what that law says, and then make sure that you can do the wireless charger. Right, okay, let's have a little look through the chat here. What on earth were we talking about before I got here? If a question asks us to comment on something, a website that we're supposed to we agree or disagree? Yeah, comment questions are normally going to be calculate something and say what it's like or what it's not like, or apply a law or something, apply an idea to say whether something is valid or invalid. Yeah, so comment is kind of like trying to make it a bit trickier. They're expecting some kind of conclusion based on some evidence maybe you've calculated or that you know. If we have to measure displacement from a normal, do we use vector maths and draw the sum, the horizontal and vertical components? I tried paper 1 yesterday and got this one wrong. Measure displacement from a normal, is that physics? Do you mean in terms of an angle from a normal? I mean, so we measure, normals are lines at right angles to surfaces, aren't they? And we measure angles between rays and normals, so that's what I would be thinking of there. Normal just means at right angles too. Nice, you guys are chatting. Yeah, sorry it was a bit late today. I just had a chat with somebody who wanted some advice on something. Nice chat about aiming for these A stars, yeah. Excellent, and then we were here. I mainly do Edexcel, but you know. Yeah, this is all coming from my 4G. I will be doing some stuff from home, so sometimes I look a little bit rubbish, I'm sure. I always look a bit rubbish, don't I? So sometimes, sorry about that. Hopefully the sound, I think the sound's normally all right. Hi, Anthony. Good to see you. My pleasure, Lane. Yeah, we were just talking about Hubble's law. So if you look back on the, look in the description, there is a whole playlist of these daily revision questions for you to go through. And the feedback, I always feedback the next day on the previous day's question, basically. Yeah, the graph kind of is and isn't there. It's kind of there because you do need to know that the further away from us something is, the faster it is moving away from us. And the evidence for that is redshift. And you need to know at GCSE that this is evidence for the expanding universe. And then you also have this cosmic microwave background radiation, which is strong evidence for the Big Bang theory. So it is there, but it doesn't explicitly say, know that this graph is this shape or anything like that, I don't think. Okay. Yeah, did that make sense then, the angle from the normal? So you always measure, say, whenever you're measuring a ray, the convention is, we could measure the angles anywhere, but the convention is you always measure between a normal, which is a line at right angles to a surface, and the ray. Okay then, dudes, I'm going to say ta-ra then, and I'll see you tomorrow. This phone can be wirelessly charged using electromagnetic induction. Explain how the wireless charger works, giving details of the design and operation of it. That's the GCSE. Everyone can do that. And then A-level students refer to the correct law of physics to justify the choices in design and operation. So I've really made that hard for you, A-level physicists. GCSE kids can definitely have a go. Hopefully you are benefiting from reading the A-level ones, and the A-level ones are thinking, wow, these GCSE students are good, so I need to make sure my A-level is higher. Displacement is 5 meters, 36 degrees from north. Oh yeah, well, so displacement is vector, so it has an angle. So you're basically drawing a line which represents 35 meters, and it's 36 degrees from north. So it's you know, from north is a bearing, so 36 degrees from north that's the way they've given you that direction for that vector. All right, nice one. You actually sometimes study. Yeah, you clearly do. You're doing very, very well.